Hey there. We're going to go over some notes for Newton's first law. And before we jump into it, we're going to review some property of matter information. Now, most of this will be a review from your chemistry class, but we're going to take a second and just go through this real quick. And if we ask ourselves, what is matter? If you remember matter, it's made up of these fundamental particles. And these fundamental particles include things like protons, neutrons, and electrons. Now we also know there's quarks but we're not gonna really worry about that right now. So we have these fundamental particles that make up matter, and we also have what's called an object. And an object is just a collection of matter. So these fundamental particles, they make up matter, and then this collection of matter then is an object. And when we study the motion of an object, we don't really consider those fundamental particles that make it up. So, for instance, if we have a runner here and they're running a race, um, when we analyze the motion of that runner, we're not going to consider the internal functions of their body. Okay, so it's just going to be that person, and we're not going to worry about anything else. Now, if we were going to analyze the chemical reactions of that runner and their performance, then yeah, we would include that internal structure of the runner. But in our case, in physics, we're going to treat objects as if there's no internal structure. And so a lot of times what we do, instead of drawing the actual object, since we just consider that to be an empty object, we'll just draw, say, a box. Okay, so sometimes people will draw a dot or a circle for the object, but again, we just consider it to be this empty structure. And there's some properties of an object that we have. One is the internal mass of the object. And the internal mass, that's what causes the object to resist changes in motion. Okay, and so it's measured in kilograms. And then the symbol that we use is an M. Another property that we have is the gravitational mass. And the gravitational mass of an object, it's also measured in kilograms. But the symbol we use is the M subscript G. And that gravitational mass, that's what causes the object to exert gravitational forces on another object. We also have density, and you probably remember this one from chemistry. Density, it's measured in kilograms per meter cubed. And density is just that mass per volume. Okay, the symbol that we use for that is that Greek symbol rho. And another property that we have of an object is electric charge. And the electric charge, that just causes an object to exert electric forces on other objects. Okay, so the unit that we use for that is a capital C coulombs. And then the symbol that we use is a capital Q or sometimes a lowercase q. Now with the changes that were made in our curriculum, we're not going to really get into electric charge. You'll really see that once you get into AP Physics 2. And so that's the properties of objects. And then sometimes though we have a collection of objects, and that's what we call a system. So a system is just a collection of objects. So an example of this would be, let's say that we have a track, and on that track I have this cart 1 right here, and then over here on the other side of the track I have another cart, and this one could be moving this way, this one could be moving this way. And if I'm analyzing both of these carts at the same time, then that we would consider both objects. So that would be a collection of objects. So then that would be a system. Okay, so a system is just a collection of more than one object. Now, when an object is in motion, okay, and we're studying the motion of an object, we consider one, the change in position of that object, and two, the time that it takes for it to change that position. And an example of this would be like our bowling ball lab, right? Our bowling ball lab, we were studying the change in position of the bowling ball and the time that it took for it to change that position. And then that's where we came up with that equation for our velocity, right? Velocity was equal to our change in position over the change in time. And if you remember the change in position, we called that displacement. Not distance, but it was the displacement. And so an object's change in position, that could be vertical or horizontal, like the bowling ball that was horizontal, and in that case we used an X. Okay, so if it's horizontal, then we would use an X. If it's vertical, then we'll use a Y. And so, for example, if I throw a ball up in the air, then the change in position then is a vertical change. So I would just have a Y instead of an X. Okay, so we can interchange the X and Y depending on if it's a horizontal motion or if it's a vertical motion. And how an object moves, the motion of that object, it really depends on the observer. So, for example, if we have a truck here, and at the back of a truck is a box, and then we got somebody standing on the truck and they're just staring at that box. But over here on the side of the road, we have another person and they're also just staring at that box. And then a few seconds later, if the truck is down here and the box is still right there in the back of the truck and they're still staring at that box, and we ask this person in the back of the truck, what was the motion of that box? Well, from their perspective, they would say it didn't move, right? And the person on the side of the road, if we said what was the motion of that box, they would say it moved from, let's say, 0 meters to 5 meters. So it moved 5 meters. So the motion of an object, it really depends on the observer. Okay, so you need to keep that in mind when we're studying the motion of an object. And if you remember from the bowling ball lab, when we were analyzing the motion of that bowling ball lab, we analyzed it graphically. Okay, we made a graph, and that was a position time graph. And when we graphed that motion of that ball, we came up with these linear lines. And so we had three different lines. One had a steeper slope. One of them started here and had this negative slope. Okay, so we analyzed the motion of this object using a graph. And if you remember, we were able to take the slope of that to then find the velocity or the motion of the object. And if you remember, when we have a linear line, that indicated that it had a constant velocity. And so when we have a constant velocity, What that means is that all the forces are balanced. So it has these balanced forces. Now, forces can be balanced in one of two situations. Okay, the forces on an object will be balanced if it's moving at a constant velocity, or if the object is at rest. So in either of these two situations, it would indicate that we have balanced forces. And that's where we get Newton's first law. So Newton's first law says that an object will stay in motion with a constant velocity, or it will stay at rest if there's balanced forces. Okay, sometimes this is referred to as law of inertia. Okay, so if you might ask yourself, well, what is inertia? So inertia is just an object's resistance to change motion. And so an object's inertia, it really depends on the mass. Okay, so if we had a bowling ball in lab and we were rolling it down the hallway, and if somebody was standing on the end and had to stop that bowling ball, and if I substituted that bowling ball with a tennis ball, you ask yourself, in which situation would it be harder to stop the ball? It would be with the bowling ball because it has more mass, right? So it has more inertia. If I have a big boulder just sitting in front of me, and then I had a small rock in front of me, and I ask myself, in which case would it be harder to move the object? It would be with the big boulder, right? Because it has more mass, so it has more inertia. Okay, so that's all the inertia means. And so the law of inertia, or Newton's first law, again states that an object will um, stay in motion with a constant velocity, or it will stay at rest unless we have these unbalanced forces. Okay, so that's what Newton's first law is. Now, in the next video, we're going to go in a little bit more depth and kind of defining, well, what is a force? Okay, we're going to look into this word a little bit more, and how we can make these force diagrams and analyze forces on an object.